This Sudoku by David Filmer is called unsolvable because it cannot be solved by conventional methods, even the most advanced ones. So we're going to take a different approach to it and see it as 9 interlocking number grids. In other words, we'll try to solve for one number at a time until we can see a clear path to a solution. And we'll do that specifically by looking for where the placement of a given number will reproduce all the other missing instances of that number. This has worked well for a couple of other puzzles on this channel. However, in the case of this Sudoku, it's not possible to generate all the instances of any number by putting in just one instance. So we'll have to start with 2. But as we'll see, things move smoothly from there. Now, one good principle of Sudoku solving is go where the numbers are. And so, since 6 is the best represented number, we might want to start there. We can see some places where the remaining 6's have to go in one of 2 cells. But the thing is, no matter how we fill those in, different arrangements of the grid of all the 6's, it doesn't really get us anywhere. It doesn't really provide for progress. So we need to look at another number. The 8 is one of the numbers that's next best represented, and it's a very promising potential arrangement of all the 8's. It commends itself for a couple of reasons. One is, there are a couple of places on the puzzle where other numbers can go in only one of 2 cells, and that arrangement of the 8's generates both of them. Now, we could aim the 8's right at those numbers. If we filled in those, it would eventually fill in the 8's just as shown. But to demonstrate the method, let me put an 8 where it's shown there in purple, and that will generate the 4. Let's put another 8 there. That'll generate the 1. And from those 2, we get the remaining 8's. And I said this arrangement of the 8's commended itself for 2 reasons. The other reason is, once we have it in place, we can put just one 9 there. It'll get us all the other 9's. And as we'll see, it'll actually generate the rest of the numbers in the puzzle. Once we have the 9's in place, we can pick up the 2's. Getting the 2's generates a couple of 6's, and that allows us to get the rest of the 1's. And they give us the rest of the 6's. So what we have now is a grid in which the numbers 1, 2, 6, 8, and 9 appear in every block. We've only picked up a couple of the other numbers, and we did that right at the start. So this Sudoku is almost like 2 half Sudokus sharing the same space. But there's just enough of a constraint that we can get the rest of the numbers. For example, that has to be a 5. The 7 is the last number left in that column. We see that the 3 and the 5 cannot go in those blue squares, so they must go where indicated. So that has to be a 4. That gives us that 4. And we can see that the 4's must go in those 2 lower blocks where the colored cells are, which means they can't go in the colored cells in that left-hand block, so the 4 must go there. That gives us that 4. We can pick up a 7 that way. And similarly, we can see that the 7's must go in the shaded cells in those 2 blocks on the bottom, meaning they can't go in those 2 shaded cells in the center block, so the 7 has to go in those 2 columns as shown. And similarly at the top, the 7 has to go in those 2 columns, which means that in the middle block, the 7 can't go in the shaded cells, so it must go there. Well, clearly we are squeezing every possible number that we can out of the grid at this point, so I think it's time to take a step back and look at the big picture. And when we do that, we realize that the 3's and the 5's and a few of the 7's are in this arrangement. And if we follow potential paths, potential ways that the 3 and the 5 can configure, we see that one of them leads to a contradiction. If that's a 5, that has to be a 3, that has to be a 5, that has to be a 3, that makes that a 7, so the cell in the center there has to be a 5, which is a contradiction, which means that must be a 3, and that gives us the 3's and the 5's in the middle blocks, and the 1's in the upper blocks. And then we can see that either of the 5s plus that 3 mean that the block at the top center has to be a 7. And that gives us the rest of those numbers. And from here, it's not difficult to fill in the rest of the numbers. And there's the solution. So just to review, we started out by getting all the 8s. That gave us a couple of key numbers. We got the rest of the 9s and the 2s. That gave us a couple of 6s, which enabled us to get all the 1s and the rest of the 6s. We filled in a few remaining numbers, and that enabled us to see this arrangement, which resolved that way, and this led to the solution of the puzzle.